We are live. What's popping, y'all? Shout out everyone in this bitch. I am about to get into a lab right now. Y'all ain't even know this side of me, bitch. Oh, let me stop cursing. I forgot I'm throwing this on YouTube. But y'all don't even know this side of me, but I am a tech professional and I am converting into cloud engineering, DevOps engineering. I'm certified in AWS, Solutions Architect Associate, AWS DevOps Pro. Um, so today is day one of my 60-day challenge. Trying to do a lab once a day for 60 days in a row to up my skill in cloud and security when it relates to cloud engineering. So essentially becoming a cloud security engineer or a cloud engineer or DevOps engineer, I am going over those skills. So of course that includes networking, that includes cybersecurity, that includes Terraform, which is IAC, infrastructure as code. It includes Kubernetes, um, which is containerizing applications. Of course, we have Docker. We're gonna be getting into all of that in these 60 days, and each study session will go on YouTube. Again, that is where we're at. So day one, here we are. Let's get to it. So step one is build the VPC foundation. For everyone that doesn't know, VPC is virtual private cloud. We'll be building that within the AWS console. I have that open on another tab. And these are our steps. We're going to be creating a VPC with a CIDR range block. With those IPs right there, we have a public subnet, private subnet, etc. I am going to be learning as I go as well. So yeah, I'm not going to say I'm perfect at this. I am improving, and that's why we're here with the 60-day challenge. Let's get into it. First is, let's get to the VPC. So we're going to go inside our console. We're going to search VPC for virtual private cloud. Let's Google everything as we go so we can all be on the same page. So an AWS virtual private cloud is your own isolated private network within the AWS cloud. So it acts like a traditional network in a physical data center, but it utilizes the scalable global infrastructure at AWS. So this is essentially similar to an on-prem environment. It is just your cloud environment. It's basically how you set up your internet, right? Your internet within your when I say your internet, I really mean your network. It's creating your network within the cloud. So we're gonna. This is what assigns your IP device, your IP addresses to devices. Of course, we're gonna be creating different subnets for different networks. We'll have some rules in our routing table. Our internet gateway is what allows our VPC to connect to the public internet. And then we're going to create some security groups and some network ACLs, which is access control lists, because we don't want everyone to have the same privileges, which is a cybersecurity term called least privilege. You want to have, you want people to only be able to access what their role details. You can't have, it's like essentially like the janitor can't have, I was about to say the keys to every room, but technically they do. You get my point, though. So let's get back to it. So we're going to start with the VPC. So we're doing everything from the console today. So we're going to create the VPC here manually. And this is what we're going to do. Let me go back to here to see our rules. So our CIDR block is going to be 10.0.0.0.0/16, which gives us up to 65,536 IP addresses. So that means 65,536 devices can connect to this network. So that's essentially a very large network. But that's what we're going to do. Our public subnet is going to be within here, within this IP block. So let's get that set up. First of all, I don't think I set that up here. Do we see public, number of public subnet 02, customized subnet cider blocks? Here it is actually. Here it is. So we are gonna set that up right here. So 10.0.10/24. So we're gonna take off this here and add 24. And I love this right here because it actually shows us how many IP leases we will have. Within this subnet, 10.0.1.0/24, we have 256 IPs. And of course, wait a minute. I think I'm doing this in A. Public subnet, private subnet. Let's verify with ChatGPT because it's saying A and B. I think I'm only supposed to be doing this, and maybe I'm supposed to be doing it for both. I guess I'm setting up 2 because one will be a backup. Let's confirm that with ChatGPT. So how I do things with ChatGPT is if I have a question, I send a screenshot and I drag and drop into the chat and I ask it questions. So let's verify. So for the public subnet, I'm creating it in East A and East B. What is the reason, if so? I think it's for redundancy, but we'll see. And let's type in the private block as well while we're here. 2.0/24. I believe it was 24. We'll look again. It is a 24 block. So get rid of 144.20.24. All right, great. Now let's ask chat. Now let's give it a new screenshot because I just made some changes. We're gonna get rid of this one and slide this one over. All right, let's see what chat says. So chat is my handy dandy best friend. It lets me know if I'm doing things correctly or not. So this is essentially how you should be using ChatGPT. Use it as an assistant. Don't so much rely on it to do everything for you, but use it to help you understand things. So this is the overlap. Subnets inside the same VPC cannot have overlapping cider ranges. So that's not even possible. Okay, why would we use both 1A and 1B? An availability zone is a separate failure domain within the AWS region. So redundancy. If your whole application lives only in 1A and the AZ has a major problem, then your application is down. But if you have it in B as well, then it will use the other availability zone, which is a term we call high availability, which is also redundancy. But tonight, simplify it. For day 1, change number of public subnets to 1. Is that possible? No, it's not. 0? No, it's not possible. It's not possible. It does not let me change it. I didn't think it was. It doesn't let me change it to 1. I believe 0 or 2 is my only options. By the way, I'm going to have to keep clicking over it just to read chat. Yeah, so sorry if you see that on YouTube, me clicking over at Twitch. Actually, I'll pull it up on my phone so I don't have to keep clicking over and I can talk to anybody who joins. I know there's a few viewers in here a minute ago. But yeah, we're going to keep going. Yeah, you're right. In the AWS VPC and more wizard, the subnet count selector often gives you 0, 2, or 4, not 1. So for this lab, do this instead. We're going to set the public subnets to 0 and private subnets to 2. I said 0. Set public subnets to 2, private subnets to 2, and our NAT gateway will be 0. But fix the cider so each subnet is unique. So we're going to have to change this to 10.2.0. Where did public go? Customized public. That should be 1.24. And then this should be 2. 10.2.0/24. And our private is obviously going to be different. We're going to see in a second. I'll exit out Twitch since I have it up on my phone. And our private is going to be 10.0.11.0. Okay. So 11 and 12.0. 11.0, 12.0. Awesome. So we have this set. And okay, cool. So we used the same prior, but we just fixed it. So yeah. All right, it wants to see a little more prior to me submitting this. So let me zoom out so I can screenshot everything. Yeah, I'll let chat see it. Right here, chat said, go ahead and change those 4 CIDRs. After that, send me the top of the wizard so I could check your VPC, CIDR, AZ count, and DNS settings before you create it. So it's going to verify that all this is correct information. We could view it ourselves real quick. So right now, the resources we're creating is a VPC and more. The and more is the IPv4 CIDR blocks and all the other details below. Our CIDR block's going to stay 10.0.0. Yeah, of course, we're keeping that as the whole CIDR block. So CIDR block is essentially your full IP range. So we're going to actually look up the definition of that. IPv4 CIDR block. So a CIDR block is a group of IP addresses written with a base IP and a / suffix. Example. So it's just a group of your IP addresses written with the base IP. So, and for our example, ours is the 10.0.0.0/16. That's our full CIDR block. So that's the starting IP and the sizes of our VPC using CIDR notation. You know, this is really a mathematical equation. Back in A school, when I was in the military, I had to memorize this. But I will admit, and also when I was getting CompTIA Network Plus, I had to memorize this. Although nowadays with all the tools we have with AI, and you see how in the AWS console it automatically tells you how many IPs you got, I kind of just quickly Google this. It is good to know it by memory, but if you could figure it out, you could figure it out. Of course, 2 IPs are always being used. Those are always reserved. But yeah, let's go back. So, yep, top half looks right. I could confirm from the screenshot. Everything looks good. Everything looks good. Now scroll down a little further. It wants to see the 4 subnet. It wants to see the rest of my stuff. Let's read it. So, scroll down a little and send me the section showing the 4 subnet CIDRs, the NAT gateway setting, VPC endpoints, DNS options. I want to verify those before you click create. So it wants to make sure our 4 subnets, CIDRs are accurate, the 2 publics and 1A and 1B, and then the 2 private and 1A and 1B. It wants to make sure those are accurate, which I'm certain they are, because this is actually what we used. And it wants to make sure our NAT gateway setting is good. We'll Google everything. We're going to treat it as if we don't understand anything. So the NAT gateway is our network address translation gateway. It is a managed cloud service that allows resources inside a private subnet to safely connect to the internet or other external networks. So it's a service that allows resources inside a private subnet to safely connect to the internet. So it translates the private internal IP address into a public IP address for outbound traffic while blocking unsolicited inbound connections from the outside. So how do you say this simply? Simply, how do you say what this means? Because that could be a mouthful. Let's try to simplify things. So, because that's the way it sticks in your head. Think of a NAT gateway as a one-way security door for your private digital network. It lets your internal computers look out at the internet to download updates or grab info, but it keeps the doors locked so outsiders cannot see inside or come in uninvited. Boom, that sticks way better. So within your private subnet, that is private. We don't want people from the outside to enter in that subnet. So, but we still need those devices to be able to connect to the internet so they could download updates or grab information from an API. So to do so, we have to create a NAT gateway, which allows our private digital network to connect to the outside. It's essentially a one-way door. It's not a revolving door where you could come in and come out. Only the private devices could come out and get what it needs. That's it. No one could come back in. Technically, things can come back in. That's where there are some cybersecurity risks, but it's designed for devices to not come back in, essentially. All right. Let's make sure it has everything else it needs. So let's go. Send a screenshot to chat. Make sure this is accurate. Pretty sure it is. Another thing it mentioned was VPC endpoints. Endpoints can help reduce NAT gateway charges and improve security by accessing S3 directly from the VPC. By default, full access policy is used. You can customize this policy at any given time. So again, this is to help make sure security in our NAT gateway is good, because we don't want any intruders to get through. And that allows us to connect directly to an S3 bucket, which is very good. VPC endpoints to none. Right. Okay, so chat wants us to change our VPC endpoints to none. Right now, S3 gateway selected. It's wrong. It's not wrong, but it adds another concept we don't need yet. Later, we'll deliberately build VPC endpoints and talk about why private resources can reach S3 without traversing the public internet. Also notice AWS is creating 3 route tables. We got the public route table, the private route table 1A, private route table 1B. That's actually useful. Both public subnets can share the public route table. Awesome. That's good to know. While the private subnets have their own route tables and no direct route to the internet gateway. That's perfect. So the private subnets don't have a way outside yet, and they're in their own route table, but the public share the same route table. That's a good distinction to notice. A subnet is not public merely because we named it public. Ooh, great to know. A subnet becomes public because its associated route table has a route to an internet gateway. And an instance also needs an appropriate public IPv4/elastic IP, that's what EIP, plus security rules to actually communicate over the internet. That makes a lot of sense. So change the S3 gateway to none and create the VPC. All right, we'll do that now. Just let them keep boiling.
The water is out of it. It's burning.
Just turn it down.
It's burning.
Okay. All right, it was created. Awesome. All right, I'm gonna submit this submission and let it know it was created, and give me a few minutes. I need to go check on some mashed potatoes. Let that keep cooking. Yeah, let that keep. I said just let it keep cooking. All right, I'm back, and let's get to it. All right. Perfect. VPC creation succeeded. You've got the VPC, four subnets, internet gateway, and 3 route tables all created. Now click View VPC, then go to Route Tables. Open the one named something like Project blah blah Project RTB Public. Go to its routes. You should see something like, when you see that, answer in your own words. Why does the 0000/0 internet gateway make the associated subnet public while the private subnets are still private? All right, let's go do that. So we're gonna do View VPC. We're gonna go to Route Tables, and we're gonna find the one that it's referring to. I have a lot of projects in here. Is there a filter to put? Is there a filter to put the most recent? Which one would it be? Day 4 VPC. I have a few in here. Then go to the route table ones. Project RTB Public. I actually don't see that. Let's ask chat real quick. Which one is it? How can I tell? Yep, the reason you can't tell yet is your route table page has a refresh. Look at the top right. It says last update 19 minutes ago. Oh. Okay, there we go. I didn't even notice that. Here it is right here. This is our private number 1, our public. So these are the 3 we're looking at. The 1 public route table and then the 2 private ones. So within here, we're going to, what is the next step? Okay, I am, it's there now. All right, actually it's there now, but we could move back up to the last prompt and actually see what it wanted me to do. Okay. You should see, go to this routes tab. Okay, so click it. Routes. Let's pull this up. Destination. Here's our internet gateway, and it's active. All right, so the reason it's active is because this is a public subnet. Public subnets are given an internet gateway off rip because they're a public subnets. These are created to access the internet. The private subnets, let's click one. What I believe is these do not have an internet gateway because they're made private. You have to give them a VPC to connect to the outside. Now let's tell chat that. The public subnet is made to be accessible to the internet due to it being public. So by default is given an internet gateway. On the contrary, a private subnet is the opposite. It is created to be private, so you would need a VPC to connect it to a internet gateway. Let's see if I'm right. You got the general idea, but there are 2 important corrections. A subnet is not public just because AWS labels it public. It becomes public because its route table has a default route like internet gateway. I mean, that's what I meant, because when you create a public subnet, it creates a route table for the public routes. So, okay. But I'll explain it this way. That means for any destination that isn't inside this VPC, send the traffic to the internet gateway. That means for any destination that isn't inside this VPC, send the traffic to the internet gateway. That means for any destination that isn't inside this VPC. Okay. Okay. The private subnet, break that down a little better. Okay, the private subnet is private because its route table does not have a route to the internet gateway. Right. And you don't need a VPC to connect it to internet gateway. The subnet is already inside the VPC. Okay. The difference is the route table path. Okay. A strong interview answer would be a public subnet is a subnet whose route table has a route to an internet gateway, typically 0.0.0.0/0, which leads to the internet gateway. That gives resources in that subnet a path to the internet, assuming the instance has an public IPv4 address or elastic IP and its security controls allow the traffic. A private subnet doesn't have a direct route to an internet gateway, so its resources aren't directly reachable from the internet. Correct. One more thing to lock in. The internet gateway alone does not make the subnet public. The internet gateway can be attached to the VPC, but the subnet's route table does not point to it. The subnet still has no internet path. Okay, so the route table is the big distinction that I've been leaving out. So the route table determines if these public and private subnets can reach the internet gateway within a VPC. So the VPC has the internet gateway attached. The subnet route tables points to the internet gateway. You have to set that up. Instance has public IP plus security group and network access control list allow it. So instance can actually communicate with the internet. That distinction is exactly the kind of thing Cloud Engineer Interviewer will test. So I want to break this down better. Think of the route table. Okay, so think of the route table. Okay, think of the route table like a set of directions. Your VPC is 10.0.0.0/16. That means anything from roughly 10.0.0.0.0 to 10.0.2.55.255 is considered inside your VPC. Right. So your route table has a route like 10.0.0.0/16, which is local. That means if the destination IP is inside my own VPC, keep the traffic inside the VPC. Example, your EC2 is 10.0.1.10, which is within it. And it wants to talk to another EC2, which is within it. AWS checks the destination, which is within the VPC. The IP falls inside, so AWS uses the local. Oh, no internet needed. Okay, so it has your local route table. Okay. Now imagine your EC2 wants to reach 8.8.8.8, which is Google. If you know, you know. That is inside. That is not inside 10.0, so it's outside. So it needs to look through the route table for the internet gateway. It looks for another matching route. It sees 0.0.0. So the internet gateway allows for all IP addresses. That's sticking. There it goes, y'all. That makes fucking... Oh, I can't curse. That makes sense. I'm about to check on these mashed potatoes in a second. Go ahead and whip them mashed potatoes up, baby. Treat it like, you know what I mean? Like you whipping up on the stove. I don't know nothing about that, though. All right. But AWS uses the most specific matching route. So if the destination is internal, AWS chooses the more specific local address. If the destination is external, which 8 out of 8, the internet route doesn't match. So AWS falls back to the internet gateway. Great. Great. Now question. If you're trying to reach an outside IP, but your security group slash NACL or your route table doesn't allow it due to not having a route to internet gateway or just the rules in your security group slash NACL, what happens? So what I expect to happen is an error. Exactly, and the traffic fails at whichever control block it hits first. Think of the outbound traffic like it has to pass through a chain. So the EC2 goes to the security group, NACL, route table, internet gateway, internet. If any required piece says no, the packet doesn't make it out. Awesome. So of course it doesn't make it out. We'll get deeper into that later. All right. Great. What's next? All right. Next is EC2 in the public. Next is EC2 in the public subnet. Prove that the path actually works. Go to EC2 launch instance and use EC2 launch instance and use. We're going to use Amazon Linux. So now we're going to create an EC2 instance in the public subnet, and we're going to prove that it can talk to the internet. So now that we set up the public, we set up our VPC. Within it, we had our public subnet and our private subnet, which created 3 route tables because we created 2 public IPs, A and B, and we created 2 private, A and B. The public IPs can share the same route table. So we have one public route table, and the private IPs have their own route tables. So we have private route table A and private route table 2. So now we're going to create a EC2 instance, which is just a virtual machine, a computer within Amazon, and we're going to test and see if it can actually reach outside of the network. It looks like we're gonna run an Nginx server, which is a popular web server, and then once it's running, we're gonna grab the public IP address and we're gonna open it. If it loads, then we've proven that the public IP plus our security group plus our NACL and route tables. We didn't really set up a security group or NACL, but we definitely set up the public IP, the route table, the IGW, the EC2 service is about to get set up right now. So this is the test. After this, we're gonna break it down, but let's get it. So I'm at EC2. I need to go to instance, and we're gonna go to launch instance. So within here, I'm gonna name it network. What do I want to name it? What are we naming it? I don't even know what we're naming it. It didn't really tell me a name. Nope, it didn't really tell me a name. But okay, we're gonna just put what's required. So we have Amazon Linux, small free tier. I want the free tier. Yeah. Let me get the free tier eligible. Boom. I don't want to get charged for this. Network project VPC. That's what it says for network. Do I change that? Let me see. Actually, I think ChatGPT is a little outdated. Let's see what it wants us to put. Name. Where does project VPC go? So we're gonna actually confirm with chat real quick that it is talking to me on an updated settings. ChatGPT likes to use outdated information a lot. All right, so we got our name, day 1 public web. We'll just copy and paste that. The name is just the EC2 instance tag, so you can recognize it later. For project VPC, scroll down network sections. You already have open. There's a VPC drop down. Click the VPC drop down. Choose the VPC you created earlier. Okay, so this is where we are attaching our VPC that we had created. Here it is right here. So this is what's giving us our IPv4 CIDR block right here. Good catch, actually. So that is, we need to use the VPC that we created earlier. So now we're gonna choose the subnet, and we're starting with our public A. We're gonna add our subnet right here. We're using public A. Project subnet A. Yep, this is the one I could tell by the IP address, 10.0.1.0. There it is there. Anything else? Make sure auto assign IP public is enabled. So we don't want a static. We want to auto assign our public IP. Enable it. We don't need nothing static. And for now, under the security group, SSH2 is do what? Let me go back real quick. SSH22 is my IP. What's up, Unbashed? AI viewer streamboo.com. I don't want no bots, homie. I don't need bots, man. And for now, under the security group, SSH22. Anywhere in my IP. HTTP 80. So we're setting up our SSH port 22 and our port 80 HTTP to my IPs for the SSH, and then the HTTP, the public HTTP is gonna be anywhere IPv4. SSH. Where is that at though? SSH. Where's HTTP, bro? It's not within here. Oh, we gotta add it, don't we? HTTP port 80 anywhere. All right, great. So let's send a picture of this back to chat. Make sure it looks good. So the EC2 instance itself gets whatever name you want. All right. You good from what I could see? Yup. Did it already give me an IP? Oh, it sure did. That warning at the bottom expected because HTTP is open to the internet. That's cool for a public web server. That's intentional, of course, to make sure the upsettings are still blah blah blah. That's all good. And we're gonna press launch instance. I don't think we need a key pair, but let's see what chat says. I don't think we need a key pair at all. Okay, so we do want a key, just in case we got to connect to the Nginx server. All right, that's fine with me. All right, what is it, create new pair? There goes the key. We're going to do RSA and PIM. RSA is just a type of encryption. .pim, we're using a Mac OS, so we're using that for our SSH, our key. It's just the format. Oh, we're not going to use RSA. We're going to use ED25519, which is a private and public key pair. All right, so launch instance. We just got the key. Don't really need that myself. It's successfully connected. Let's go back to instances. And we're going to grab the IP of it. Public IPv4. We're going to type that bad boy in here. And make sure. Oh, it says we can't reach. Oh, wait. I got to put HTTP. It's HTTP, not HTTPS. So let's take out the S. No? All right. Let's troubleshoot. Let's figure out why. Make sure that is the IP. See, here it is here. Did it finish running? It did. All right, let's add this here too. Let's figure out why. Oh, it didn't load, so we need to SSH into it. Maybe it knew we weren't gonna create it correctly, and this is a part of the troubleshooting. We have to figure out why Nginx server is not working. So it gave us a hint. So the error connection said refused. Where are we seeing the refused at? Not too sure where it saw that at. A refused connection usually means we reached the server, but nothing is listening on TCP port 80. If the route table, SG, or NSL were silently dropping your traffic, we'll more commonly expect the browser to sit there and eventually time out. That is what happened. And I see another clue. Your EC2 status check still says initializing. It's not done. No wonder. Okay, so we're going to let it finish initializing. I think that's why we're getting these errors. I didn't expect the error. Let me go check on these mass potatoes real quick, and I'll be right back. So we're going to definitely just wait until it finishes. So right now we are watching this, the status check initializing. Once this is finished initializing, we can really see if it's working or not. BRB. All right, I'm back. Is it still initializing? Let's refresh. All right, it finished. We're going to refresh our web page and hope it works. Let's open it from here. Hope it works. If not, we're going to definitely have to SSH into this. Figure out what's going on. Again, I don't remember opening our port 443, so I don't know why it keeps prompting that, but maybe that's normal. Okay, it's not opening. Okay. It says 3 out of 3 checks passed, still not opening. So alright. We're gonna SSH into Nginx so we can actually figure out what's going wrong. Fun. So on day one, we ran into a troubleshooting. Ran into something we need to troubleshoot. So let's get to it. So let's open up terminal on our computer. That is similar to command prompt on a Mac. I mean, on a Windows computer. So, same thing. So, terminal is open. Let me bring up my browser so we can see both at the same time. We got some commands we're gonna have to enter in. So, let's run this so we can get the key. I wanted to explain these commands. Well, we're SSHing. Let's Google what chmod 400 does. The command chmod 400 sets a file's permission so that only the file's owner can read it, while completely blocking everyone else from reading, writing, or executing to it. Okay, so we're the only people I'm the only user that's allowed to read this file, which is our SSH key, which we want to do because we don't want anyone else to have access to our SSH key unless we purposely want to give them it. Yes, we are for sure connecting. All right, so now we're inside our Linux Nginx server. We're going to do a sudo command to figure out the status of Nginx, see if it's running. It cannot be found. So our issue might be Nginx was never installed. So of course it won't load. That makes sense. So as you can see here, we just seen that the package Nginx is not installed. So of course we're not going to be able to get to the IP address. Makes a lot of sense. So we're going to copy this. Yep. Nginx never got installed. Explain those commands too. Explain those commands as well. We're going to really break down everything. I want to be able to explain it all. And I want every viewer who happens to see this, hopefully it's one person, to learn one thing. That's all I care about, is that we get to learn together. So Nginx was never installed, so nothing was listening on port 80. Boom. There goes the issue. So the sudo system CTL status Nginx, system CTL talks to system MD, the Linux service manager. This command asks, is there a service named Nginx and what state is it in? Our results turn unit Nginx service cannot be found, meaning the system doesn't even know about an Nginx service on this machine. The RPM space Nginx. RPM is the package manager database tool for RPM-based Linux systems like Amazon Linux. TACQ means query. So this asks, is the Nginx package installed? Your results, package Nginx is not installed. My guys, you will always run into Linux commands. So you may as well get a little familiar with Linux and terminal. That confirms Nginx isn't present. Curl makes an HTTP request. So it's basically just requesting data to see if the HTTP could respond. It's like a ping. Localhost means this exact EC2 instance itself. So, yep. So now we need to install Nginx, and this is gonna fix our issue. So we're using a sudo command to install Nginx, and then we're gonna enable it at the same time. So again, what we learned here is if your browser fails, SSH into the server, so test it locally. If the local test also fails, fix the service. If local works, investigate the network path. Makes sense? Makes sense. So it just got finished installing, and we are going to refresh our web page and see what happens. Make sure our EC2 service is still good. All right. It's loading pretty slow, which is giving me a little worry. makes me wonder, is it working? I don't think so. Nope, it failed. So we have some more troubleshooting. Look. Oh, I'm sorry. We have to verify. We never verified. So let's do that real quick. Make sure the IP didn't change. So it says it's enabled and it says it's running. Hmm. Hmm. Let's make this. Let's enlarge this and read the actual log itself. Read the terminal. So I ran the command. Do. So it's installing there. Installed it. Install complete. So now we are testing. And says it's loaded. It's active, is running as of 52 seconds ago. That's odd. Why would it not load? Let's check one more time. Still no. Okay. Let's paste our log. Web page isn't loading still. Interesting. We're going to figure this out. That's what I said. So we're not even using HTTPS. We only allowed port 80. So we did not allow. There we go. That makes sense now. We only allowed port 80. We never allowed port 443. We would have to go in there and allow that port as well. Remember, we only did SSH, which is port 22, and we did port 80, which is HTTP, not HTTPS. So our web server is listening on port 80. It is live. We are good. We're now good. And it means you just prove the whole path works. Awesome. Next, we're doing the fun part. It says we're breaking it intentionally. So now we're going to remove the HTTP port, the port 80 rule, and we're going to see if it works. Obviously, it should not work. So we are going to go to EC2 instance group. Would that be a security group? I don't think so. Where would this be in exactly? Yeah, it is. Security group. Okay. We're allow SSH and HTTP. I don't think this is the project. Is it? Probably is. Man, I have too many VPCs in here. I need to start cleaning this up. Go back. Lord, did we name it anything? No. Is that it? I forget what I named it. All right. We are going to ask for ChatGPT's help right here because it memorized exactly our VPC instance. Can you verify which one it is? We're going to clean this up. What's up, T-Blunt? We're going to clean this up and make sure we get this a little more organized. Yep, yours is Launch Wizard 3. You can verify it from two ways. So we could verify it from our security group name or our VPC instance. Again, I'm not memorizing this whole VPC instance. Luckily, ChatGPT memorized it, so we're going to Launch Wizard 3. Here we are here. We did not name it. Next time, we are going to name our security group so we know which one it is, so it's quicker and easier. Here we are. We're going to open this up, and we're going to get rid of our port 80 rule. So we're going to, what do I want to do? Edit. We're going to edit the inbound rule. and we are gonna delete it. Once we delete it, we're gonna save it. We're gonna reload this, and it will crash. As we can see here, it's loading slowly, which is a sign that it is crashing. Again, pop quiz. Why does it say not secure? That's because we're using HTTP, which is listening over port 80, which is not port 443, which is HTTPS, which makes our internet browser secure. You don't want to have if any website has HTTP, don't trust it, because that means it is clear and your data is visible, aka your username and passwords. Everything is visible if it's HTTP. Normally hackers use HTTP. HTTPS is for security reasons. Again, you can see that the server is loading very slow, so it's crashing because it's looking for that port 80, but we just deleted it. So now let's see what chat wants us to do before you tell me what error the browser gives you. So the browser will load and load until it says unresponsive because it is looking for port 80 which we deleted. Exactly. More precisely, the browser sends a HTTP request to the server's public IP on TCP port 80, but the security group no longer permits that inbound traffic. Because the security group is stateful, it silently drops denied traffic. The connection usually hangs until the client gives up and reports a timeout. So the interview grade explanation is the web server is still running and listening on port 80, but the security group no longer allows inbound TCP/80 traffic. The packets are dropped before they reach the EC2 instance, so the browser eventually times out. Perfect. All right. Next, put the HTTP/port 80 rule back. Confirm the page loads again, and then we'll break the route table next. So as we can see, it's still loading. It's never gonna work because it's looking for that port 80. It's gonna take forever. So now we're gonna edit inbound rules, and we're gonna add a rule. We're gonna add HTTP, which is port 80, as you can see by default. Our IP address is going to be anywhere IPv4, so this is giving it a DHCP IP address, not a custom static IP. And we are going to save the rule, and now we're going to reload this page, and it's going to work. As you can see, there's no more loading. You know what? I'm going to close the page out just so we can see that again. So let's go back to our instances. I have that open right here. We're going to open the address, and it's going to load correctly, given that it's updated. All right, give this a minute. Make sure everything's saved in the meantime. Route 3, port 80, perfect. Oh man, do I have to reinstall? Do I have to SSH back in and reinstall Nginx? I hope not. I have to SSH back in after adding port 80 to port 80 to reinstall Nginx. Oh my god, I might have to SSH back in, y'all. Okay. Oh, I'm sorry. Here's the catch. It's on HTTPS. Get rid of that. It's HTTP. There we go. Here we are. Our instance is back loaded. So now we are off to the next thing. We're going to break our route table. Awesome. Let's break the route table. By the way, bae, I'm almost done. So we could eat in a minute. Yes, please. Okay, boom, go to VPC. So now we're going to break the route table. Let's go to VPC and then our route table. Here we are. We're looking for the one we created today. Gosh. Listen, y'all. Great advice is naming these things. So I did name it. So here's our public. Are we going to break the public? Most likely. Yep. On the routes, you should see local boop. Edit routes to temporarily remove the internet gateway. All right, so we're going to go in here, go to routes, and we're going to get rid of our internet gateway. And now we're going to see what happens when we get rid of our internet gateway, which is actually interesting because I'm curious myself. Boom. So we just got rid of the internet gateway. We're going to save. We're going to refresh so we can see the change. Refresh right up at the top. Route table is gone, and we're going to refresh our Nginx server. What happens is it's going to crash because there is no internet on the route table. So it's going to be listening for port 80. But our subnet will not be able to leave our network because there is no gateway. So it will not reach the outside. It won't reach the internet. So Nginx is still running. So locally, we'll be able to SSH into Nginx and see it's still running. Our security group still allows port 80. So we're allowed for port 80 to listen for this Nginx server. But the subnet no longer has a route to from the internet through the internet gateway. So the browser should eventually time out. App healthy. So that gives you another troubleshooting later. App healthy plus security group healthy plus route broken equals unreachable. That makes a lot of sense. After you test it, tell me exactly what Chrome shows, and I'll have you explain why the return path is broken too. So we're going to wait for this to crash. Let me go check on the fool one last time, and I'll be right back. This is way better than everything. They're just reading in silence. Ooh, love some mashed potatoes, man. Oh my god. Hey, babe, we got. Oh, we did watch episode 8, didn't we? All right. It's still crashing. It's still crashing. The browser is just loading and loading. Again, I don't really want to have to wait for the error message because it might take a while. Yeah, that's exactly what we expected. Now the failure is routing, not the app and not the security group. So now the failure is routing. So of course we don't have a route table that's pointing to the internet gateway. So the Nginx process is still running. Port 80 is still open in the security group, but the subnet has effectively lost internet connection. The really important part is the return path too. Even if traffic somehow reached the instance, the response still needs a valid route back out to the internet. Without the default route to the internet gateway, that path is broken. So let's add it back. Explain this a little deeper. And simpler. So we're going to add the internet gateway back. And then, of course, the site's going to work. After that, we're going to break the NACL. Is NACL break the last thing? Sorry, guys, I just need to get to dinner. So we're going to edit our routes. We're going to add the internet gateway back, which is 0000. Internet gateway. Create. Huh? What do you mean? Oh, there we go. Okay, boom. I just added it back. Let's press refresh. And finally, there we go. We're back in action. Yes, simpler version. When your browser asks the EC2 server for a web page, communication goes both ways. Your browser sends, give me the web page. And the Nginx has to send back, here's the web page. So even if the request gets to the EC2 instance, the response still needs a valid path back to your computer. When you remove the internet gateway, you basically told the subnet you no longer know how to send traffic to the internet. So Nginx may have the response ready, but AWS has no route telling the traffic how to leave the VPC. So Nginx basically has the response. It received it, but it doesn't know how to return that message. That's what we're talking about. So NACLs, our last intentional break. Okay, let's go. All right, let's go ahead and do our last break. Then we'll basically review everything we've talked about, and that'll be it. I restored it for sure. All right, VPC, network ACLs. That's where we're headed to yet next. I don't think we really even created one for this. I don't recall doing it, but let's see. Project VPC. Oh, yeah, we did. Here we go, right here. All right, so we're gonna click it. Inbound rules and send a screenshot. Let me show chat. We only have one rule associated, it looks like. All right, so now we're seeing what happens when you set a rule within your network access controllers. Here's the important NACL concept. AWS evaluates NACL rules from the lowest number upward. Stops at the first match. So current HTTP/80 comes in. HTTP packet rule 100. Actually, let's understand this. Here's the important NACL concept. AWS evaluates NACL rules from the lowest rule number upward and stops at the first match. So currently HTTP/80 comes in. HTTP packet hits rule 100, allow all traffic. It matches, and then it's allowed. It never reaches the deny. Let's break HTTP. So we're gonna click edit inbound rules, add a new rule. Rule number 90, and we're gonna put a deny on. We're gonna put a deny. And why the number 90? Because it must be before 100. Because the larger number, it starts with the lower number. The rules with the lower numbers is what gets applied first. Once it matches a rule with a lower number, then the numbers afterwards doesn't even matter. All right, so let's do it. We're gonna create this. We're gonna break the HTTP by creating an inbound rule that blocks it. So add new rule. We're gonna turn it to 90. Custom TCP. No, we're gonna turn this to HTTP. And deny. And we are gonna make sure there's no source. Of course not. We're gonna save the change. So now that we saved it, did I create it as TCP? I didn't even notice. I did. Thank you. So now we're gonna refresh, and it's not gonna work. So now our traffic looks like this. Our browser sends a HTTP request to port 80 because it's HTTP. The internet gateway then sends it. The internet gateway is there through the route table. It then hits the route table, and the route table talks to the NACL, and it checks that there's a rule that denies it. So EC2 never receives the packet. Even though your security group still says HTTP 80 allow, it doesn't matter. The packet was already killed at the NACL. So you see, NACL comes before your security group. One other thing I want you to notice from your screenshot, this NACL associated with 4 subnets, so this is the default NACL currently protecting all 4 subnets in this VPC. In a more carefully segmented production design, we could see use separate NACLs for different subnet tiers. All right. Yep. Done. So as we could tell, it's not going to load. I will have to delete the rule. All right, good. Now you just created the NACL failure. The key difference between the security group test is the security group applied to the EC2/ENI. It's stateful, only allow rules, return traffic for allowed connections automatically permitted. The NACL applied at the subnet boundary. Stateless can explicitly allow and deny. Rules are evaluated by number. Return traffic must also be allowed separately. What you just did was Rule 90 deny TCP/80, which beat Rule 100 allow all, because lower number rules are evaluated first. Remember that. So the packet path become browser, internet gateway, route table, NACL Rule 90 deny, a packet drop. The EC2 instance never even got a chance to see the request. Oh, that's key. So the EC2 instance never even got to see it. So the Nginx server never even saw the request because the NACL denied it. Now remove Rule 90, confirm the site loads again, and then we'll wrap up. It'll quiz me on the 4 failure types and make you explain the full packet path like I'm in an interview. So let's go ahead and remove Rule 90. We'll delete this rule. We'll save it. We'll reload our Nginx web page. It will load this time. There you go, it loaded. Awesome. So now, okay, quiz time. Let's go, quiz. Let's get this right, y'all. Let's see what's going on. So bet, day 1 quiz time. This is only on what we actually covered tonight. VPCs, subnets, routing, internet gateway, security groups, NACLs, ports, Nginx, and troubleshooting. Don't look anything up. I want to see what actually stuck. After you finish, we'll attack whatever I've missed. First question. An EC2 instance is in a subnet whose route table contains 10.0.0.0/16 local and 0.0.0.0/0 internet gateway. What does the 0.0.0.0/0 route do? So what this does, it allows all public IPs, sends all IPv4 traffic, including VPC local traffic, to the internet gateway. Allow inbound TCP port 80 through the instance security group. Provides a default path toward the internet gateway for destinations without a more specific route. Automatically assigns public IPv4 addresses to every EC2 instance in the subnet. Let's break it down. Let's slow down. Okay. So an EC2 instance is in a subnet whose route table contains 10.0.0.0/16. So that's the IPv4 CIDR block. And that's the local communication. That's the local network. And that's the internet gateway. So that allows IPv4 traffic, including VPC local traffic, to the internet gateway. I think it's either A or C. I mean, what do you mean? What does the route do? I was right. Provides a default path to the internet gateway for destinations without a more specific route. All right, great. A VPC uses 10.0.0.0/16, and EC2 instance uses 10.0.1.175, sends traffic to 10.0.1120. Which route is used? All right. So the VPC is using the full network. The EC2 instance is within the network, within the VPC. It sends traffic to another device within the VPC. So it's using the local network. All right. Nginx is running on an EC2 instance and listening on TCP port 80. The route table and NACL are correct, but the securities group inbound HTTP/80 rule is removed. What is most likely browser behavior? All right, let's break this down. So Nginx is running on an EC2 instance and is listening on port 80. So we have an Nginx server that's built within an EC2 instance and it's listening on port 80. The route table and NACL are correct, but the securities group inbound HTTP rule is removed. What is most likely browser behavior? So what happens when the security group has port 80 removed? It does not automatically switch. It's going to hang and time out. Exactly. Your browser reports error connection refused for an EC2 web server. Running RPM Q Nginx on the instant reports that Nginx is not installed. What layer is the immediate problem? It's going to be the application layer because we do not have the Nginx application installed. Exactly. What is the key statefulness difference between an AWS security group and a network ACL? Security groups are stateful, NCLs are stateless. Exactly. Let's Google what that means. Stateful versus stateless. Let's look it up. Stateless systems treat every request independently and do not store sessions data locally. They scale easily but rely on external storage. Stateful systems remember previous interactions, delivering faster connected experience, but they limit horizontal scaling and require complex server architecture. Okay. That scenario is asking me, security groups are stateful. Security groups, AWS, stateful. Yes, meaning they automatically track the state and network connections to permit return traffic. Okay, great. Let's keep moving. An NACL has a rule 90, deny TCP 80 from 0.0.0.0/0, followed by rule 100, allow all from 0.0.0.0/0. What happens to an inbound HTTP packet? An NACL has rule 90, deny TCP 80. So we're denying any TCP packets on port 80 from the internet followed by rule 100, allow all. So we're going to listen to rule 90 first. The rule 90 rule comes first. There's a precedence. The lower number rules come first. An EC2 instance Nginx page works at HTTP public IP, but HTTPS public times out. The security group allows TCP 80, but not TCP 443. What explains the difference? HTTP normally uses TCP 80. Boom. So HTTP is always on port 80, and HTTPS is always on port 443 TCP. A web page fails from your laptop. You SSH into the EC2 instance, and you use curl. HTTP localhost also fails immediately. What is the best first troubleshooting direction? So you know that the EC2 instance is running because you could SSH into it. So this means there's an internet issue. Well, there's some type of network issue. So we would want to investigate the local web service first by SSHing into and make sure it's listening on port 80, the application. Whether anything is listening. Okay. Which statement most accurately describes why a subnet is considered public in AWS? Its associated route table has a route. Excuse me? Which statement most accurately describes why a subnet is considered? Oh. Its associated route table has a route to an internet gateway. I think its network ACL allows all traffic. Because a private, let's go with A. Awesome. Its associated route table has a route to the internet gateway. Nice. An EC2 web server is healthy. Inbound TCP/80 is allowed by the security group in NACL, and it has a public IPv4 address. You remove the internet gateway from its public subnet route table. Why does internet fail? Subnet no longer has a default route for internet, including surface. Exactly. It's the first one. We just went through this. And that is it. You got all perfect score. You got all 10 questions right. Awesome. Next quiz. I'm not doing another. No, I'm good. I'm good. One quiz seemed good enough for me, y'all. 10 questions. I got it, man. 10 for 10. We did good, y'all. So day one was very productive. Again, we built the VPC slash subnets, understood public slash private routing. We launched into the EC2. We SSH into the Linux Nginx server. We diagnosed Nginx not being installed. We understood the difference between port 80 and port 443. We broke and fixed the security group, broke and fixed the route table, broke and fixed the NACL. We learned stateful security groups for stateless network access control lists. Scored a 10 out of 10 on the quiz. That is enough for today. Thank you, everyone, for being here. And that is the end of this. Again, we'll be back at this tomorrow for day 2. This is just day 1. All right. See y'all later.